Okay, hi everyone. So like I said in class, I'm going to upload the solutions to the questions that we didn't get a chance to do together. I know I said I would do 4, 5, and 6, but seeing as the other class did not get a chance to do question 6, it's unnecessary to pull ahead of them for no reason. So I'm just going to do the solutions to number 4 and number 5, and then after your assessment on Friday, because it won't take the whole period, we'll do question number 6 and maybe even another implicit differentiation question after. So first, let's get started here. It says, the point P with coordinates PQ lies on the graph of, and I've got my equation over there, x to the power of 1 over 2 plus y to the power of 1 over 2 is equal to a to the power of 1 over 2, and the tangent to the curve at P cuts the axes at my two intercepts, so my x and y intercept, and I need to show that m plus n is equal to a. So, starting off by differentiating with respect to x, I'm going to get 1 over 2, x to the power of minus 1 over 2, right, using my power rule. Here, same idea, but I'm not differentiating with respect to y, so even though I'm going to get 1 over 2 y to the power of minus 1 over 2, I still need to write my either my y prime or my dy over dx. For the sake of keeping my equation as clean as possible, I'm just going to use the notation of y prime, but of course y prime, the notation is the same thing as dy dx, so if you'd like to use that notation, you're more than welcome to. And here, when I isolate, I just need to isolate for y prime, right? So for the first thing I'm going to do is move this over, and I'm also going to get rid of my negative exponents and turn the exponent itself into a root. So what this is going to be is 1 over 2 root y times y prime, right? That's what this term is going to become, will just be equal to negative 1 over 2 root x, right? This term becomes that when, and of course it's negative because it moves over to the other side of the equal sign. So then y prime is just going to be this term right here, so negative 1 over 2 root x divided by 1 over 2 root y. And now, of course, I want to simplify as much as I can because I don't want to end up with a fraction over a fraction. So just recall, I have one fraction over here, minus 1 over 2 root x divided by 1 over 2 root y. So, when I turn this division sign into a multiplication sign, I have to take the reciprocal. And when I take the reciprocal, I end up with minus, what do I have here, 2 root y over 2 root x, and of course the 2's simplify, and I just end up with minus root y over root x, which of course I can combine the square roots to just end up with minus root of x over y. Okay, that's as simple, or as much as I can simplify it, I mean. But at this point, now I can plug in my point PQ. Obviously, I don't have any values, but I am going to plug in my variables because I want to find an algebraic expression to represent the slope when my my derivative is, for y prime when x is equal to p. That was the word I was looking for. So y prime when x is equal to p is just going to be equal to minus the square root of q over p. And now that I have the slope of my tangent and I have a point, even though I don't have the exact values, I have the algebraic representation, I can write it into point slope form. So I'm going to have, point slope form. Okay, so I get y minus q is equal to negative the square root of q over p x minus p. And I want to algebraically manipulate this into slope-intercept form because it's going to be useful for the step that comes after. So for now, I'm just going to isolate for y, and I'm going to end up with negative q over p times x, right? This is essentially my mx term, and now my y-intercept is going to be written as two separate terms because I can't group them together, but of course they're both constants because I do not have my my x variable on either term. And now, because the 2 points that I was given in the initial question are my 2 intercepts, I can plug those in, right? So my first x-intercept always occurs, and any x-intercept always occurs when y is equal to 0. So I can do that and plug it into the equation. So I've got, first I'm just going to plug it in, then I'll rearrange and simplify. So I've got 0 is equal to minus qp times x plus q plus root q root p. Okay? And now, when I rearrange, of course, I'm going to end up with x is equal to, isolating all my terms, right? Moving these 2 over, and then dividing by my square root, or sorry, the square root. But when I divide by this square root, I can just multiply by its reciprocal. So you're going to see what's going to happen. So I'm going to end up with, let's not skip any steps. So for now, I'm just going to leave the square root here so no one gets confused. And it's equal to q plus root q root p. Okay. So now, because all I did was just move this term over to the left side, and now I'm going to divide by this by just multiplying by the reciprocal. So x will just be equal to this over here in brackets, my not so beautiful looking binomial, but that's okay. And then multiplied by, instead of q over p, it's going to be p over q. Obviously, you're welcome to just write divided by and then this radical, but this way I don't end up with a fraction, so it's a little cleaner. So my x value, specifically for this point, remember, is n. So this equation, it's also the same thing as writing n is equal to all of that, right? I could write out the equation again, but it's just a waste of space. So this would be my first equation over here. Okay. And now I just have to repeat the process, but for my y-intercept, right? So my y-intercept occurs when x is equal to 0. So what do I have here? I have y is equal to minus, oh, sorry, not minus anything, because that entire term just disappears. The minus square root of q over p x, because it's just multiplication by 0, so it just disappears. So I just get q plus root q root p. And this, again, remember, is equal to n, right? Because all the way at the top in our question, our y-intercept is given by 0, comma m. So m is equal to q plus root q root p. And now, I just need to show what the question asked for in the first place. Show that m plus n is equal to a. And that's what I'm going to write. So I'm going to give myself a little more space. So put that over here, and then continue over here. So m plus n will be equal to q plus root q root p plus, so this is my m value, and now I'm adding my n value, which is going to be, and I'm not going to write it as this square root multiplied by this bracket. I'm actually going to do the multiplication. So here, actually, for now, I'm not going to do that because I don't want anyone to get confused with the algebra. I'll just show that extra step because it's a YouTube video, so there's no time pressure here. Okay, and now this is the part where we have to make sure we expand correctly. So when I multiply this out, obviously the first few terms remain unchanged, at least for the time being. So all this gets, oh, sorry, that should be a p, not a q. And now, the root over here multiplied by q, what's another way I can write that? I can write q as plus root p over q. Actually, a smarter way to write this root is actually as two separate roots. My mistake. It'll make the simplification easier to see. Root p over root q. And what's another way I can write q? I can write q as the multiplication by the square root of q squared, right? And then that'll make it easier to see how it simplifies. And then finally here, plus, so that was just our first term. And now our second term is going to be the root of p divided by the root of q. And now it's going to be multiplied by the root of q, the root of p. Sorry, I almost ran out of room there on my paper. But now, the reason I did it this long-winded way is so no one gets confused when we get to our algebraic simplification, where this crosses out and this disappears, so I'm just left with plus root p root q, root p root q, and I'm writing it purposely this way because I want these two terms to look identical so we can make the connection easier as to what our step needs to be after. And then finally this and this cancels out, so I'm left with plus what do I have here? Just p, right? Because I've got the square root of p but then squared, so p. Okay, and now when I group my two terms in the middle, hopefully we can see the connection that we're trying to make over here. Okay, right? I've got a squared plus 2ab plus b squared, right? This is a perfect square trinomial where, like I said, a is equal to the square root of q, b is equal to the square root of p. So what this simplifies to become is, and I'm going to move over here now because I'm going to need a little bit of extra room, is root p plus root q squared. And what's another way I can write the square root of something as an exponent? I can write it as p to the power of 1 over 2 plus q to the power of 1 over 2 squared. And if we go all the way back, like all the way very back, remember that our p and q are at x and y coordinates, and it corresponds exactly to this equation right here. So if I have p to the power of 1 over 2 plus q to the power of 1 over 2, it's going to be equal to a to the power of 1 over 2. So what I'm really going to have is a to the power of 1 over 2, but still inside of my bracket that's all squared, and this exponent here and here will essentially cancel out and just become to the power of 1, so it's equal to a. And we have verified what the question asked us to do, right? Because it said show that m plus n is equal to a, and that's what we did. Okay, so I hope that made sense. Hopefully the spot right here was easy to see. I know I almost ran out of paper, but remember it's just root q root p. Alright, so please go on to the next video. Obviously the same way, I hope you tried this question first before just looking at the answer. I hope you give number 5 a try before you look at the video.